Okay.
All right.
You're shaking hands. So what's going on there exactly?
So this is just a basic operation of the arm with the robot intact. The arm is something we acquired from the Shunk company, which makes modules. The modules are actually used on both the arm and the torso of the robot. They're quite powerful. They have 500 to 1 gear reduction ratios, which is what lets the robot actually be able to stand up to full human height, which is what I'm going to show you today.
Okay. Can I do that?
Okay, so you want to do the balancing, standing. What you're seeing right now is basically the robot in a sitting configuration. So what's happening is that the robot has two possible ways of interacting with the world. He can be sitting down, and then he can drive around and then interact with the world in a statically stable. So that we don't have to worry about balance, we don't have to worry about anything, and he's able to shake hands and do whatever you want. The idea is to, first of all, we're going to add a second arm so that he can grab things, but also he's able to interact dynamically with the world. And that's the second part of this, the most important part of this robot, is that he can actually stand up and then be able to do things that human beings can do, like grab things and move them forcefully, right?
Okay.
So that's what the sensor is going to show you now. Let's do balance. Balancing.
Okay, sure.
So now he just transitioned on his own from statically stable to dynamically stable.
Okay.
Okay? And what dynamically stable means is that it's actually quite stable standing, right? Now you'd think that it's actually supported by something, but it's not. I mean, these are wheels, right? So this is kind of like a Segway. The difference between this and a Segway is he has this articulated joint and articulation here. And he can move all these joints and still be able to maintain this dynamic balance, right?
Okay.
So that's the exciting thing about the robot, that he can actually use his whole body now to actually interact with the world, okay? So, essentially, we can go up and down, okay? We can stand up. He stands all the way up. Stands to about human height, okay? So the idea was actually my height. So here we go. He's standing to about human height. He's able to still be stable at that height and interact with things. He can go down, okay? And wherever he is, so this is the important thing to note here, wherever he is, the arms are actually right out front, so he has the full workspace throughout the range of motion, right? So he can grab tables, grab, furniture, whatever he wants, and interact with it. Are we able to move the arm right now? Okay. So he can actually move around, so you can twist and do what you like. You can go say hi to Stephanie over there. Hi,
Uh-oh.
Stephanie.
So why does it have to be tied to the ceiling?
It's a safety measure.
Okay.
There's no power cables or anything. This is just a problem. So
Okay.
just a measure of, as we're doing development and testing, it's good to protect students and such.
And the safety reason is why we can't actually take it to the studio.
Yes. So the idea is to really have it contained in a space. I mean, if you want to show them a picture of what's going on, there's that thing that's actually protecting it from falling over right now on top of anybody. And we also have the steel guardrail here so that, people don't accidentally roam into the area. So right there, there's actually, that's steel down there. So people don't roam into this area. He's behind you right now.
Right.
He's actually like,
And padded walls,
the
I see.
padded walls. The padding actually serves to protect the robot more than it does the world.